Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In this subject Statistical Methods 2, we are going to study about various theories of attributes, sampling distribution, and then testing of significance of the samples being large sample and small sample. Then we are going to study about order statistics. Now to start with, in this session you are going to study about theory of attributes. Theory of attributes and then consistency of data. The objective of this session is to study about the consistency of data of attributes. So before we study the consistency of data of attributes, we must know what is attributes. Hence, some basics about attributes are studied. What is actually meant by attribute? Attribute means a quality or a characteristic. So the theory of attributes deals with the qualitative characteristics which are not amendable to quantitative measurements. Attributes means qualitative, that is it means the happiness, it means the playing, any kind of quality a person has. With that quality we cannot do the calculations, hence all the qualitative characteristics must be converted to quantitative measurements, then only we can do it statistical measurements. So the theory of attributes deals with the qualitative characteristics which are not amendable to quantitative measurements, hence statistical treatment is required from that of variables. What is meant by attribute? Attribute means the quality. Examples of attributes are playing, briskness, happiness, sadness, etc. So an attribute may be marked by its presence, possession or absence in a member of given population. The population will be divided into 2 subclasses based on the attribute. That is, the 2 subclasses is possession of the attribute as one class and non-possession of the attribute second class. This kind of classification is called dichotomous classification. The population is divided into 2 classes according to the presence or absence of a single attribute. For example, the presence or absence of an attribute may be regarded as changes in the values of a variable which can possess only 2 values, 0 and 1. This is how qualitative characteristic is being converted to a quantitative measurement as 0 and 1. 1 stands for the presence of the attribute and 0 stands for absence of the attribute. So the positive class which is denoted by the presence of the attribute is generally written in capital Roman letters as A, B, C, D, etc. A, B, C, D represents the possession of an attribute A, B, C, D respectively. And the negative class represent the absence of the attribute and it is written in the Greek letters as alpha, beta, gamma, etc. A means possession and the corresponding non-possession of the attribute is represented as alpha. For example, if A represents the attribute sickness and B represents the attribute blindness, then alpha and beta represents the attributes non-sickness, it means that healthy, and then sight, that blindness antonym is sight respectively. So beta represents the non-blindness which is sight. The 2 classes viz. A, possession of the attribute, and alpha, dispossession of the attribute, are said to be complementary classes. So instead of mentioning A bar, we will be representing it as alpha as non-possession. Okay, and the attribute alpha used in the sense of not A is often called the complementary class. Similarly, beta and gamma are complementary attributes of B and C respectively. The combinations of attributes denoted by grouping together the letters concerned. AB is the combination of the attributes A and B. That is, the member is possessing both the attributes A and B. For example, in the previous example, we have taken A as the attribute sickness and B as the attribute blindness. It means if AB is the attribute possessed by a member, it means the member is having both sickness as well as blindness. Thus, for the attributes A sickness and B happiness, AB would mean the simultaneous possession of sickness and happiness. If a third attribute C be included to represent, say, male, then A, B, C will stand for sick males who are happy. So, all the three together being possessed by a member is represented as A, B, C. It means the A is sickness and B represents happiness and C represent males. So, A, B, C will stand for a sick male who are happy. And then similar interpretation can be given to A, beta, gamma. What does beta stands for? Non-possession of B. Now, we have taken B as happiness and gamma represent the opposite of C, that is female, right. So, A, beta, gamma represent a person who is sick and unhappy, at the same time the person is a female. So, a female unhappy sick person. Similarly, A, beta, C represent a male member who is sick but happy. So, similarly, we can go ahead with this kind of representations. Then we talk about classes and class frequency. Whenever there is a classification, then we can group together into classes. So, different attributes in themselves are called different classes, and the number of observations assigned to them are called class frequencies, which are denoted by bracketing the class symbols. Thus, bracket A stands for the frequency A, that is the number of members having the attribute A, and AB for the number of objects possessing the attribute AB. Class frequencies of the type A, AB, ABC, etc. are known as positive frequencies. Similarly, alpha, alpha, beta, gamma are known as negative frequencies, and alpha B, which is a combination of possession and non-possession, are called contrary frequencies. So, A, bracket AB, bracket ABC are called positive frequencies, being the possession of the attributes. So, alpha, alpha, beta, gamma represent the non-possession of the attributes, and then they are called negative frequencies. If there is a combination of possession and non-possession of possession of one attribute and non-possession of another attribute, then such kind of frequencies will be called contrary frequencies. Alpha B is actually non-possession of one attribute, and B represent possession of another attribute. The same attribute cannot be possessed and non-possessed. So, one should be non-possessed and another should be possessed. So, it represents two kinds of different attributes. Then we talk about order of classes and class frequencies. Now, these are all actually basics to study about the consistency of data of attributes. So, a class is represented by n attributes is called a class of nth order, and the corresponding frequency is called the frequency of the nth order. So, when you represent the attribute A as a class in A bracket, it means it is a class frequency of order 1. Then AB, AC, beta, gamma, etc. are all class frequencies of second order, because it represents two attributes, and then when it is grouped, it is called a class frequencies of second order. Then A, B, C, A, beta, C, alpha, beta, C, etc. are called class frequencies of third order, and so on. Now, capital N, the total number of objects or total number of the members of the population considered without any specification of attributes. We are studying about the members of the population, then the N represents a total member We are not bothered about whether the population members is having the attribute or not attribute, non-possession of the attribute, then this is reckoned as the frequency of 0 order. That is, we do not know whether the member is having the attribute or not having the attribute. Then n represent the total number of members, and since it is called a frequency of 0 order. Thus, in dichotomous classification with respect to n attributes, the number of class frequencies of order R is NCR into 2 power R. How this NCR into 2 power R? Since R attributes out of n can be selected in NCR ways. There are n attributes. Out of that, we are talking about the number of class frequencies of order R. So, R frequencies has to be chosen from out of n attributes, and it can be selected in NCR ways, and each of the R attributes contributes 2 symbols, that is possession and non-possession. One representing the positive part means possession of the attribute, and the negative part means non-possession of the or dispossession of the particular attribute. Thus, the total number of class frequencies of all orders for n attributes, we have to just take this summation R is equal to 0 to n NCR into 2 power R. This gives you the total number of class frequencies of all orders. So, NCR into 2 power R being expanded, NC0 into 2 power 0 plus NC1 into 2 power 1 plus NC2 into 2 square plus etc. last NCN into 2 power n. This is 1 plus NC1 into 2 power n. So, all these being representing the expansion of a binomial series. Therefore, it is 1 plus 2 whole power n, like a plus b whole power n. This is equal to 3 power n. Okay. In particular, for n attributes, the total number of class frequencies of different orders are given as follows. For order 0, it is 1, and for order 1, it is NC1 into 2 power 1, that is 2n. Similarly, NCR into 2 power R, this represents for order R is equal to 2. R is equal to 2, it is NC2 into 2 square. Similarly, for order n, it is NCR into 2 power R, and then ultimately we have NCN into 2 power n. Thus, in the case of n attributes, the positive class frequency of order R has NCR elements, their total number being summation R is equal to 0 to n NCR. This we have to expand, because the positive class frequency of order R has only NCR elements. When we talk about the total class frequencies, then we have to talk about 2 symbols, possession and non-possession. We are talking about only positive class frequency. Positive class frequency means only 1 power R, NCR into 1 power R. So, this being expanded NC0 plus NC1 plus NC2 plus etc. plus NCN, and this expansion is again a binomial series expansion, where you have 1 plus 1 whole power n is equal to 2 power n. Thus, in class of attributes A, B, C, we have the order class frequency of order going to be 3. The total number of class frequencies is 3 cube. So, that is 3 power n, we have just seen 3 power n, where n is equal to 3 here because of the attributes A, B, C. Therefore, we have 3 cube. So, there will be total number of class frequencies as 27. Okay, let us see how this 27 comes. First of all, talk about the order frequency, order, then frequency. Order 0, the total frequency n. For 1, we have A, B with the 3 symbols A, B, C. only one order. So, it should be written as only one letter in a bracket, because it is going to be a frequency of order 1, and then its complements alpha, beta, then gamma. So, this contributes 6 numbers. 6 is being arrived as NCR into 2 power r, and n is equal to 3, r is equal to 1. Therefore, NCR into 2 power r gives you 3C1 into 2 power 1. So, 3 into 2 we get 6, and these are 6 in number. So, let me see how many frequencies are there with the class frequency of order 2. Order 2, you have to write it as AB, then A beta, then AC, then A gamma, similarly BC, B gamma, then its corresponding contrary frequencies, that is alpha B, then alpha beta, similarly alpha C, alpha gamma, then the contrary frequency for B is beta C, then beta gamma. Totally how many frequencies you are having? 12. How is it 12 arrived? N is equal to 3 and R is equal to 2. So, NCR into 2 power R is equal to 3C2 into 2 square. 3C2 is 3 into 4, you get 12. Now, we are going to talk about order frequency, total number of class frequencies of order 3. How we are going to arrive at 3 is ABC, A, B, gamma, its class frequencies, then A, beta, C, A, beta, gamma, then its corresponding contrary frequencies alpha, B, C, alpha, B, gamma, then alpha, beta, C, alpha, beta, gamma. How many are having? 8. How is this 8 arrived? Again, n is equal to 3, r is equal to 3, NCR into 2 power r is 3C3 into 2 cube, which is equal to 8. Now, next we are going to talk about relation between class frequencies. All the class frequencies of various orders are not independent of each other, and any class frequency can always be expressed in terms of class frequencies of higher orders. Thus, we have the total number of members in the population, capital N, can be represented as with respect to the attribute possession and non-possession. So, class frequency A and then class frequency alpha together represent N. Similarly, with respect to attribute B, class frequency B and then its contrary beta. Similarly, with respect to C, C plus gamma, etc. Also, since each of the alphas or A's can be either be B's or betas, we have A is equal to AB. This kind of relation is very important. We are going to use it for future work. What is that A? A can be represented as possession of AB plus A beta. Similarly, alpha can be represented as alpha B plus alpha beta. Then similarly, B can be represented as AB plus alpha B. A is possession of attribute A along with B, and alpha B represent possession of not A but B is present. So, B is present in both the cases. So, totally if you want to have the class frequency of B, then you should take AB plus alpha B. Then talking about the non-possession of the attribute B, beta is A beta plus alpha beta. A represent possession of attribute A along with beta, and alpha beta represent possession of not A but beta is present. Beta is possession of not B. Similarly, the class frequency of order 2 can be represented as a class frequency of higher order, that is A B C, A beta, A B gamma. A B is common in both the cases. You can just vary the third variable C plus its complement. So, A beta can be written as what is another variable which is missing here, C. So, A beta should be there in both the cases. So, A beta C plus A beta gamma, and then alpha B is equal to alpha B C plus alpha B gamma, and then alpha beta can be represented as alpha beta, one variable is C, and alpha beta gamma, and so on. Next, what is meant by ultimate frequencies? The class frequencies of highest order are called ultimate class frequencies, and the respective classes will be called as ultimate classes. So, the classes of highest order are known as ultimate classes, and their frequencies the ultimate class frequencies. It may represent the highest order. In case of n attributes, the ultimate class frequencies each contain n symbols, and since each symbol may be written in two ways, with positive and negative part, we have the class frequency as n. Example, A or alpha, beta or B, B or beta, etc. The total number of ultimate class frequencies is 2 power n. So far, to reach at this topic consistency of data, we have been discussing some of the basics of theory of attributes. Now only we are going into the exact syllabus, that is theory of attributes. We need the consistency of data. So far we have been studying the basics. All the basics are required, notations are required to study further. So therefore, we have been studying the basics. Now next we will get into the consistency of data. What is meant by consistency of data? Any class frequency which have been or might have been observed within one and the same population are said to be consistent if they conform with one another and do not in any way conflict. For example, the figures A is equal to 20 means possession of the attribute A is with 20 persons, and possession of AB is equal to 25, which is contrary, right? The possession of attribute A are there with 20 members. So, AB represent possession of attribute A and then B. So, it should be less than 20 only. Already we have represented the bracket A means possession of attribute A is only 20, and AB represent possession of attribute A and then B. Therefore, it cannot be 25, and this is not conflicting with the data given. Therefore, it is not a consistency or data. A is 20 and AB is 25 is not consistent. Therefore, the data is inconsistent, as AB cannot be greater than A. AB means representing the possession of A and B. It should be less than 20 only if they are observed from the same population. So, consistency of a set of class frequencies may be defined as the property that none of them is negative. None of the class frequency is negative. This is basic condition like for consistency. Otherwise, the data for class frequencies are said to be inconsistent. Since any class frequency can be expressed as the sum of the ultimate class frequencies, it is necessarily non-negative if all the ultimate class frequencies are non-negative. This provides a criterion for testing the consistency of the data. In fact, we have the following theorem which gives you the necessary and sufficient condition for a consistency of data. This theorem is used for testing the consistency of the data. Now, the necessary and sufficient condition for the consistency of a set of independent class frequency is that no ultimate class frequency is negative. In this session, we have dealt with the basics of the theory of attributes along with the notations. To study about the consistency of the data, these basics are required because the notations and the frequencies are being used for studying the consistency of data, that is required. So, basics was studied and then we started with the consistency of data discussion along with the conditions for consistent and inconsistent data. Based on the discussion, these questions are frequently asked. What is meant by an attribute? Discuss about the class frequencies of the attributes. Find the total number of class frequencies in case of two attributes. Thank you.